Hello everyone. Now we'll see how to conduct experiment on phase shift keying using IC4052 IC. So basically this is the PSK circuit, phase shift keying circuit. Phase shift keying is a digital modulation technique where carrier phase is changed based on the digital message. So specifically in binary PSK, carrier phase is shifted between 0 degree and 180 degree based on the digital input. So when message input is 1 or when digital input is 1, it is represented by 0 degree carrier, and when message input is 0, then it is represented by 180 degree phase shifted carrier. So this is the binary PSK, binary phase shift keying. So here we have to set carrier input of 5 volt 1 kilohertz, 5 volt amplitude and 1 kilohertz frequency. Since we require 180 degree phase shifted carrier, we are using inverting amplifier here. This is op-amp based inverting amplifier. So here we are using coupling capacitor. Then feedback resistor is 1 kilo ohm and input resistance is also 1 kilo ohm. Since it is in the inverting mode, voltage gain expression is AV equal to minus RF divided by R1. By substituting 1K and 1K, we get minus 1 as a gain. Therefore, we can write output voltage equal to gain into input. Therefore, output V0 equal to minus Vi. So, at pin number 6 of the op-amp, here we get inverted sine wave. Then this inverted sine wave and in-phase sine wave both are applied to clamper circuits. So, these two clamper circuits will shift the level of the signal. So negative peak of the sine wave, it is shifted to 0. That means at this pin number 5 we get level shifted sine wave in phase carrier, and here at pin number 1 we get level shifted inverted sine wave. So both are clamped here, and this is IC4052. Inside this IC4052 we have two identical 4:1 multiplexer, but we are using only first set of that multiplexer, 4:1 multiplexer. This pin number 9 and 10, these two pins are the select lines. Pin number 9 is most significant bit, pin number 10 is least significant bit of the select line input. So with these two select line, now we can give 4 combinations 0 0, 0 1, 1 0, 1 1. But our experiment is on binary PSK. In binary PSK, we have only two possible message inputs, like input bit 0 and input bit 1. Therefore, pin number 9 we have to ground. So, ground this pin number 9. Then, these two combinations are not at all possible here. You can discard it. So, 0 0, 0 1. These are the possible combination. When input is 0 0, now pin number 1 will be selected as output. That means whatever signal appears at pin number 1, it will be passed to the pin number 3. So we get PSK output. So this is phase shifted signal, 180 degree phase shifted carrier. Similarly, when input is 0 1, then whatever signal we have at this pin number 5, it will be passed to the pin number 3. So here we have in phase carrier, therefore we get 0 degree carrier here. So this is how PSK signal is generated using this IC. So pin number 16 is VCC, and here pin number 8 is grounded. So this 16 and 8 together it is used for biasing this IC. 3 is output, 5 and 1 are the carrier inputs. Pin number 10, here we are applying the message input. Message frequency is 250 Hz and amplitude is 5 volts. So here we have to apply a square wave with the offset. Now let us set the input first. And this is signal generator. From this signal generator, we have to apply sine wave of 1 kilohertz frequency and 5 volt amplitude. Let us make our direct connection. So signal generator is connected to the CRO. Let us set the amplitude now. As we can see here, now amplitude is around 4 volt. Increase the amplitude. Now here we can see that 2.5 divisions are covered in the CRO. So 2.5 into 2, altogether amplitude is 5 volt. Next set the amplitude, frequency. So adjust the frequency knob. Now frequency is set to 1 kilohertz. So 1 kilohertz frequency and amplitude is 5 volt. Next we have to check intermediate signal at this point. So as I told previously, this is the inverting amplifier. So here at pin number 6 we should get inverted sine wave. So direct sine wave is applied to channel 1. Now we have to check the output at pin number 6. So I am using this second channel now. See, our probe is connected to second channel. I am connecting this to pin number 6 of the op amp. Now this CRO probe is connected to the capacitor, that means it is connected here, and this is pin number 6, this point. So we are comparing these two waveforms now. Here in phase sine wave is applied, so we should get inverted sine wave at this point. So this channel 1 is a in phase carrier, and here we have to compare this is the output. As you can see here, this is the in phase carrier, and using inverting amplifier of op amp, we have shifted that phase by 180 degree. Now our carrier is ready. We have both 0 degree phase shifted carrier and 180 degree phase shifted carrier. Now we have to apply this to pin number 5 and pin number 1 of the IC4052, that is 2:1 multiplexer. Now we have to use. Next let us set the message input, square wave of 5 volt amplitude and 250 hertz. So I am connecting this CRO probe to channel 1. So this is our square wave. Let us set the amplitude now, 2 volt per division. Increase the amplitude. So 2.5 divisions into 2. So 5 volt amplitude. Next set the frequency to 250 hertz. I am using frequency knob of the signal generator. I am adjusting that frequency now. Okay. So 250 hertz and 5 volt amplitude. Next let us apply the offset, DC offset. Ground the signal. Align that line to time axis. Keep it in DC. Now as you can see here, there is no offset applied, so the square wave signal is symmetrical about the time axis. Now use the DC offset knob. Slowly increase the level. So now negative peak, it is on the time axis. So now square wave offset is also set. So DC offset set, amplitude 5 volt and 250 hertz frequency. So message and our carrier both are ready now. Now let us connect this message signal to pin number 10 of CD4052. This is ground point. Next, carrier is already connected here, and the second channel, this shows the output now, overall output, this PSK output. Keep CRO in the dual mode. This is our overall output. As you can see here, for logic 1 or for high level, here we have carrier with 0 phase, and for low level here we have carrier with 180 degree phase shift. So clearly we can see that discrete phase shifts at every transition point from 1 to 0 and 0 to 1. There is a 180 degree phase shift that we can clearly see from the waveform. So these are the waveforms. This is our message input with 1 0 1 0. So square wave with offset. It's a unipolar representation of binary signal. So 1 0 1 0. And this is our carrier input with 5 volt amplitude, and this is our PSK output. So for bit 1, waveform starts from here. As you can see, this is in phase, and for 0 it starts from negative, so 180 degree phase shift. So this is the overall output for PSK, phase shift keying. Thank you.